Determine if these sequences are arithmetic. If yes, then list the first term a sub 1, the common difference d, and the simplified formula for the nth term a sub n. And the sequences we're going to work with are part A, -7, -4, -2, 0, part B, -3, 3, 9, 15, and part C, 1, 5/4, 3/2, 7/4. For our solution, we'll start with part A, and we'll start by finding the common difference. We're going to find the difference, and if it is common, then we can say, yes, it's arithmetic. And if it's not common, it's not arithmetic sequence. So we'll check the common difference, and we'll do that by finding difference 1, which I call d sub 1, where I take the second term and subtract the term that came before it, -4 minus a -7, because -7 came before -4. And that equals a double negative, -4 plus 7, it equals 3. That's our difference. Let's look for the next difference, d sub 2. That's where we take the third term, -2, and subtract the term before it, -4. Double negative makes that -2 plus 4, which equals 2. There's a problem right there. Our difference between terms is not common. So we go, uh-oh. Difference is not common. And if the difference is not common, that means that our sequence cannot be arithmetic, because that's the whole definition of an arithmetic sequence. We get the same difference between successive terms. So we saw that the first sequence, part A, is not arithmetic, so we don't need to go any further with that question. We can go on to part B, where we're going to find the common difference, if it exists, between the terms in the second list. So d sub 1 is the second term minus the term before him. 3 plus 3 is 6. D sub 2 is 9 minus 3. Do you see that? 9 is the third term minus the second term, that's the term before it, 3, and we get the same difference, 6. I hope this continues. Let's look at d sub 3. That's where we take 15 and subtract 9. And the difference is 6. So we're celebrating now. Hooray! We have a common difference, and that value, d, is equal to 6. That's one of the things they asked us for. Also, the first term in this list, a sub 1, is found by just looking at the list. The first term, a sub 1, is equal to -3. And then to get the nth term, our sequence being arithmetic means that we can use a formula, a sub n equals a sub 1 plus n minus 1 times d. So the nth term equals the first term plus the index n minus 1 times the common difference d. For this problem, that would be a sub n equals -3 plus parenthesis n minus 1 times 6. And when you simplify that by getting rid of the parentheses, a sub n equals 6n minus 9. So we found the formula for the nth term of the sequence in part B, the arithmetic sequence. It is a sub n equals 6n minus 9. Now let's answer the same question for part C. Here we're going to look up the common difference. We'll see if they are common. D sub 1 is 5/4 minus, well, let's see, what comes before 5/4 in part C? The number 1 comes before it. So we're going to go 5/4 minus 1, but we don't want to write it as 1 because these are fractions. They have to have a common denominator in order to subtract them. So we subtract 4/4 instead of 1, and the answer is positive 1/4. The second difference, 3/2 minus 5/4, well, we need a common denominator. Let's make that 3/2 written in term of a denominator 4. By multiplying top and bottom by 2, we get 6/4 minus 5/4 equals 1/4. Great, we're being consistent with our difference. Finally, d sub 3 is 7/4 minus 3/2. Get a common denominator, 7/4 minus 6/4, and that gives us 1/4. So we're having a party, hooray! We have a common difference, and that d is 1/4. And the first term, a sub 1 in the list, is, by viewing the list, we can see that a sub 1 is equal to 1. So this is an arithmetic sequence because it has a common difference. And for that reason, we can use the formula that we used before, a sub n equals a sub 1 plus n minus 1 times d. So it's 1 minus n minus 1 times d, which is 1/4. Now you simplify that, distribute multiplication, and get a common denominator, and you simplify to a sub n equals n over 4 plus 3 over 4.